Okay, and as promised, I'm going to take a look at yesterday's killer. I did solve this yesterday, so this chain of logic will be a little bit more, I'll find it a bit quicker again, I would think. So this isn't the same as doing a live solve, but I still think it's worth doing, simply because there are some interesting elements to this puzzle that we haven't come across very much when we've done Saturday Deadly Killer Sudokus. So you can see all I'm doing at the moment is just filling in the, call them the obvious answers, but the 3 and 4 letter cells, or boxes that have a very limited number of possibilities. And you can reach this position fairly quickly, and you can see also, I think, that this 9 here, well, it can't contain a 1, a 2 or a 4, so that has to be a 3, 6. So let's get that in straight away. Okay. And you can see things like this 11 plus this 20 mean that these two cells have to sum to 14. I don't think that tells us a great deal, and I think that there are two very interesting boxes in this puzzle. This box is an extraordinary box. It's a 42 box in 8 cells, and this 36 box is also fairly prodigious. But the thing that we will have to use later that's very key to note about a box this big is that a 42 box in 8 cells cannot contain a 3. So we need to bear that in mind when we're making our deductions from here on out. And the first obvious point to note is because we have a 6 here in one of these two cells, which is forcing the 6 in the 30 box down to the bottom row, this has to be 5, 9, and therefore this has to be 5, 9, because we did the logic to work out these two cells have to sum to 14. So this doesn't contain a 9 down here. Okay. One thing just to note here as well is using this 42 box. If we sum 24 and 19, we get 43. Plus another 20 is 63, 64, 84, 114 we get from summing all of the boxes wholly contained within these final 3 columns of the grid. Now that means these 5 cells here have to sum to 21 in order to ensure that these 3 columns sum to 135. And if these 5 cells sum to 21, these 3 cells also sum to 21. And again, that's something that we need to try and keep in our minds for later. And now we can use the geometry of the grid to make a little bit more progress. So let's take a look at the bottom 2 rows and see if we can use something about these 2 rows to take us further. And you should be able to see fairly quickly that these 2 cells here, we can isolate the value of these 2 cells. If we add 11, 14 is 25, 34, 41, 48, 30 is 78. So these 2 must be 12 in order for us to get these 2 rows to add to 90. And we've already got a 5 in this box and a 3 in this row, so this has to be 4, 8. So finally we've 7, 9, so this is, so now we've started to make some progress along this this bottom row of the grid, if you like, now. So this 7 is quite limited. Can't be a 1, 6 because we already have a 6 in the box. Could be a 2, 5, but if it's a 2, 5, it needs to be a 2, 5 in this direction because of this 5 here. And it could be a 3, 4, but if it's a 3, 4 again, it needs to be a 3, 4 in this direction. And here we see the 4 here rules out one of those possibilities. So this is in fact a 5, 2, like this, and this is a 2. Which means here we're looking at 3, 7, and this is a 1. Should be immediately scanning upwards to see where that takes us next. Okay, this is 2, 6 in some form. This 1 limits this to being a 2, 4 variation up here. And now we need to place 1, 3, 5 and 7 in this box somehow. I think the only thing worth noting there is perhaps that. And the reason for noting that immediately is this 26 box in 4 is actually quite a restricted box, especially because this cell is also restricted. So let's just imagine this was a 3 for a moment. If this was a 3, the other 3 cells in this box would have to be 6, 8 and 9. Well, they can't be, because this cannot be 6, 8 and 9, because we already have 6, 8 and 9 in these 3 squares. So this cannot be a 3. And one thing that's interesting to note here is that, just imagine for a minute this is a 9, this cell here. This is a 9. That forces the 9 in this bottom box to be on the left hand side, which would force a 9 into the middle column. But that's impossible because the 9 can't go in these 2 cells, and it can't go here because if there is a 9 here, there's already a 9 in this box. Yeah? So, in fact, this can't be a 9, and the 9 is in one of these 2 positions. And we can do a bit of hard work on these first 2 columns and make some more deductions, I think, because this 26 is, again, it's so limited in terms of the number of possibilities that it can contain. And that's particularly true when we combine it with the power of this 20 box in 5. See, 20 and 5 is relatively restricted, especially when you have numbers like a 5 and a 9. I mean, if this was a 9, for example, the only way of making this 20 work is if this string of 4 would be 1, 2, 3 and 5 to give us the 11 we need. Now, what does that mean? Well, it means a bit when we combine the fact, that sort of fact, with the feature that the 8s in this top box are in these cells, and the 8s here are in these cells. That means we have to place an 8 down this column. That's the first thing we can say. Now let's imagine that we put the 8 here. Can that work? Well, I'm not sure it can. I mean, clearly if this was an 8 and this was a 9, that would break. But if this was an 8 and this was a 5, that would be 13, which would mean these would have to be 1, 2, 4. But that breaks because of this 7. So in fact, there is no 8 here. Now if there's no 8 here, that means there is an 8 in one of these 2 positions, like this. That's our first deduction. But I think we can go further than that by using, again, this Sudoku technique. We've got 6's here, and we've got 6's here. That means we also have to put a 6 in this column. Obviously the 6 could go in one of these 2 positions, and that would be lovely if it did. But in order to conclude that, we need to test whether a 6 can go here. Well, we can rule out 6 and 9 very quickly, because 6 and 9 is 15, and therefore we'd have to make these 3 cells add to 5, which is impossible. The minimum that 3 cells can add to is 6. So we're left with testing whether 6 and 5 could work. And 6 and 5 I don't think can work, because if this was a 6 and this was a 5, this would be a 7. And this would be a 3, and therefore actually we'd have to put a 9 into one of these 2 cells along with the 8 in order to make, because we have to place a 9 in this column somewhere. So this 26 box would now be 8, 9 in these 2 cells, and 7 in this box. So it would be that they would add to 24. So this box would have to be a 2. Well, that's impossible. We already have a 2 up here. So the fact that there is a 6 in one of these 3 cells and it's not here means that it must be here in one of these 2 cells. And that's great because now we've got 14 here. These 2 cells therefore have to add 12, so they must be 5, 7, like that, which means we're left with 1, 3, 1, 3, as shown there. And then again, this is a really lovely puzzle, but the logic is very tight because now we've isolated the 1, 3, 1, 3 here. We can use simple Sudoku logic again with this 1. We know there's a 1 in one of these positions. Well, it can't be in the 9 because that would make the other cell an 8, which would contradict with the 8 we've already got. So we actually know that this is 1. And this is quite beautiful because now we need to think about these 3's. Again, let's scan down. Can't put a 3 here because there's a 3 in here. And we can't put a 3 in either of these 2 cells either because that will give us a 6, which will now contradict this 2 cells as well. So we're left actually with only one place the 3 can go, and that's here. I think that that is a really gorgeous piece of setting actually. It's really, really, really neat, that piece of logic there. Okay, and that gives us a couple more numbers, as you can see. Okay, so we're left with, this is forcing this to be an 8. That forces this to be a 2. This to be a 6. And you can see now that we've isolated the values of these 3 cells. This has to be 2, 7, 9. Which means that this cannot be a 9, this has to be a 5, and this has to be a 9, which is now great because now these 4 cells are indeed adding up to 11, and that means they have to be 1, 2, 3, and 5. So this has to be a 2, and this is a 5. And now let's look at this 23 box. Well, we've already got 16 in there, so these 2 have to add up to 7, which could make that a 6. Or a 4. Well, it can't be a 4 because of these 3, so it must be a 6. And this is the 1, and this is a 3. Why does this matter? Well, again, we can now use the feature of this 42 that I referred to earlier. As we draw the 3 across here, and there can't be a 3 in any of these cells. We've said there can't be a 3 in any of these cells, so the only place left for a 3 is here, which allows us to make further progress down at the bottom. This is a 9. So we still have 7 8s to place in column 4. Like that. We can still add a couple more numbers in over here. Just for good order, we can put the 5, 7, 8, I think, into these cells here. 1, 3, 4 over here. Now we can use our second interesting piece of logic to do with 3's in this puzzle, and that's looking at the 36 box now. Now this 36 box has size 6, which means that there will be a maximum of 3 numbers, well, there are exactly 3 numbers not included within it. And those 3 numbers must add up to 9, because we know that all the numbers within the 36 box are different. So there will be 3 numbers left out, and they will be the difference between 45 and 36. But how many ways are there of making 9? without using a 3, because we know that there is a 3 within the 36. Well, 612 would be one way. Then 513, no, that contains a 3. Or 234, well, that contains a 3. So in fact now, we know that there cannot be a 6, a 1, or a 2 in this 36 box. Indeed, we know the exact makeup of this box. It must consist of all of the numbers from 1 to 9, apart from a 1, 2, and a 6. So let's write those in then. So 4, 5, 7, 8, 9, 7, 9, 4, 7, 8, 9. In fact, neither. We've already got 5 in the box. So now the only place the 5 can go is here, because we know there needs to be a 5 in this 36, and we know the 5 isn't in any of these cells. So now we know indeed that there's a 4 and a 9 in these positions, and one of the two of these 3 positions, which means there cannot be a 4 here. There's going to be a 9 up here. I'm not going to note that down, but that's just forced, and this in fact forces this configuration at the bottom. Okay, like that. 4, 4, so there's going to be a 4 up here, that can't be a 1. And again, we can use some, we can look at what's missing from this column now. Well, a 2 is missing, so we know there's going to be a 2 in one of these 2 positions. Well, that means that this 1, 2, 4 combination with 7, the 2 has to be here, which forces that arrangement. The fact that there's a 2 here and here, and there's a 2 here and here, means that there will also be a 2 in one of these 2 positions. Can't be a 2 here because of this 2 down here. So I think we're left with something like this now. And we can now see the makeup of this 19 box, because we've already got a 7 and 8 in the box. But Sudoku logic is telling us there's a 3 in the box, and there's a 1 in the box. So 1 and 3 add to 4, which means that the other 2 cells have to add to 15. So, and we know that there's 7 and 8 in this cell. So we now know that this 19 is made up of 1, 3, 7, and 8 in some combination. Which now means that we have to place 5, 6, 9 up here. Like that. Again, we can see this can't be a 9. If this was a 9, this 19 gets too big, because 9 plus 3 is 12, which means we need to have these 2 adding up to 7. Well, even if this was 7, you can't have a 0 in a box, so this can't be a 9, which means that 9 is in one of these 2 positions. And similarly, we know that these 3 cells in some order are 2, 7, and 8. In fact, let's just write it out longhand just so that you see this can be 2, 7 because there's an 8 here. But imagine if this 2 was not 2. Imagine if this was a 2. That would mean these 2 cells would be 7 and 8, and this box would blow up. It would be too big. So the 2 must be here. And therefore that's a 7 and that's an 8. Which means that this is a 6, this is a 9, and this is a 5, which allows us to fill in these 2 cells and these 2 cells. And that allows us to do a bit more at the bottom here. You may remember at the start of the video we said these 3 cells have to sum to 21. Well, they do, so that's all looking good. And let's remember these 5 also have to sum to 21. So what are we looking for here? 157. Apologies. So that's 157. That. Well, that's instantly interesting in the sense that this is a 24 box in 4. So if there is a 1 in one of these two positions, the other cells have to be 6, 8, and 9, which they can't be. So the 1 must be here, which means this is a 7 and this is a 5, which means these two have to add up to 12. So they're obviously 3, 9. 3, 9. So the other cell has to be the 4. This isn't a 4. Whoops. And what are we left with? We're left with 2, 6, and 8 to place. So this is 6 and 8. 6, 8, 2, 6, 8. Like that. And in fact, you can see in this central box here that we could have placed a 7 here. 7. Which means we need to put a 6 over here. So we've got 4, 6, 8, 9 in some combination along these. Like that. And again, some Sudoku logic. We've got 2 5s in these two positions. That means we need a 5 in one of these 3 positions. And this can't be a 5. So one of these two is a 5. And that's quite interesting in the sense we're getting a seriously constrained box for this 19 now. So we've already got 10 in the box. So we've got to place. So that rules out this 6. Because if this was a 6, there would need to be a 4 in the box. Which is, I think, impossible. Maybe I've done my maths wrong. Actually, no, I'm wrong. 1, 4, and 5 is 10, so we need 9 in the rest of the box. So that rules out the 8, because that would give us a 1. And there would have to be a 7, 3 in these two positions, both of which are possible, I think, at the moment. 5, 7. Look, that can't be a 3 there. Now that 3 is ruled out, this is a 12. So this has to be a 2. 7, 2, 6, 8, 6, 8. So now remember that we said these 5 squares need to sum to 21, and we've already got 14. So these have to be 1, 2, 4. And because of this 2, this has to be a 2. We're left with 1, 4, 1, 4 here, like this, which makes this a 3, this a 1, this a 4, this a 5, this a 5, this a 7. You can see the puzzle's done now, but we'll just finish it off for good order. I think that, it's a really brilliant puzzle, to be honest, this one. Both the puzzles over the weekend, this one and the one from Saturday, have been of the highest quality, so fair play to the Times for publishing puzzles in a daily paper that require this much logic. Very pleased to see it. Yeah, seriously good puzzles. Just finishing off now. We need these to add up to 10. The only way, well, that clearly can't be an 8, it can't be a 4. 4. So it would be 6. 9. And that's how you do this excellent Deadly Killer Sudoku. Thanks for watching.